Assalamu alaikum. Good morning. I mean, good afternoon. Good afternoon. Good afternoon. Good afternoon. Good afternoon. Hello, good afternoon. Can you hear me? Hello, can you hear me? Hello, can you hear me? Hello. 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 Hello, can you hear me? Hello, Zakirullah. Can you hear me? Please speak. Like, hello. Can you see my screen?
Good afternoon, sir.
Good afternoon. Please talk. Can you hear me clearly now?
Yes, sir.
What of Zakirullah? Zakirullah, please talk. So let me know if you are there. Hello. Hello, Sakina, Abi.
Yes, sir.
Sakina, right?
Yes, sir.
Sakina.
Sir?
Now, can you see my screen? Can you see my screen?
Yes, sir.
The probability. Are you there already?
Yes.
The topic is probability. Can you see it? Is it very clear
Yes.
there?
Yes.
Mashallah. Uh, so let's start. At least this video is recording. So at the end of the class, I will share the recording video to the platform. So for those that are not around, so today's topic is probability, and you might have seen the topic before, but since you people are in SS3, so we need more. I mean, revision questions on those previous topics. Hope you can hear me clearly.
Yes, sir.
Hope you can hear me clearly.
Yes, sir.
Okay. So as I was saying, the topic is probability. So the topic is probability, and we define probability or chance as a measure of likelihood of an event happening or not happening. So as I'm tracing it now, so you can see my cursor. So probability or chance is a measure of likelihood of an event happening or not happening. And we have some terms used in probability. We have terms used in probability. So the first one is certainty. So I put down there certain. So that is probability of certainty. Then we have impossible probability. So these are the probability terms. So impossible or impossibility. Then we have the even. We have likely. We have unlikely. We have random. We have event space. We have sample space, and we have the outcome. So all these they are just terms used in probabilities. So we have some terms that are not here, like at least, at most, we use it in probability as well. So it depends on the question given. So the terms used are certain, impossible, even, likely, unlikely, random, event space, sample space, and outcome. So we also have experiment, we have random, we have conditional, we have independent, we have mutually exclusive, not mutually exclusive. So those are the terms used in probability. So now we move to the next one, which is the value of probability also lies between 0 and 1. So which means the range of probability is between 0 and 1. So you cannot have less than 0 probability, and we cannot have more than 1 probability. So if you are getting minus value answer in a probability, you are wrong. If you are getting, let's say, 1.2, 1.1, 1.3, 1.4, 2.5, that is improper fraction. So you are wrong. So in probability, we cannot get more than 1 probability. And according to this range of values, so the impossible probability is 0, while the probability of certainty is 1. So as today is Saturday, if I ask you the probability of that tomorrow will be Sunday, the probability will be 1. Definitely, because after Saturday we have Sunday. But if the question says what's the probability that tomorrow will be Monday, so we are wrong. I mean, impossible probability. After Saturday we cannot have Monday. So there must be a day before Monday after Saturday. So that is that. The range of probability is between 0 and 1. Then, and the range is given as 0 less than or equal to probability of an event less than or equals to 1. So that is probability of happening plus probability of not happening equals to 1. So in further maths, they use probability of failure, I mean success, plus probability of failure equals to 1. So as shown in the, in the probability scale below. So this is the probability scale. But according to probability of happening plus probability of not happening equals to 1, we can also have, let's say, we have a coin, and in a coin, definitely we have 2 faces. We have a head and a tail. So if I now ask, what is the probability that is not a head? So probability that is not a head will be 1 minus probability of head. So if you want to do it like that, and since we have 2 chances, that is head and tail. So if the question is probability of not a head, so it's going to be probability of tail. So you can either do it like that too. So let's check this probability scale. So for this probability scale, we have the scale ranges from 0 to what? 0 to 100. 0 to 100. Hope you can see it. Sakina, can you see it?
Yes, sir.
What of Zakirullah? Zakirullah, are you there? Okay, so let's continue. So we have 0%. 0% is impossible probability. So as I've just explained it, under probability that today is Saturday, what will be the probability that tomorrow will be Monday? So it's 0. Then we have unlikely. Unlikely to happen, that is 25%. That is 1 over 4. 25 over 100. 1 over 4. Then we have 50%. So 50% is even. So that's 50-50 chance. So the probability that uh, even is 1 over 2. That is 50 over 100. Then we have unlikely chance. Likely chance, sorry. So likely chance is 75%. So the percentage that that event will occur is
Mr. Daoud,
75. Yes, sir.
hello.
Yes, sir.
Well,
I
you
can hear
can
you.
close your camera, please, so that
Okay.
someone will be able to concentrate. Close your
Okay.
video.
Okay.
Yeah.
Okay.
Then, have you allowed them to talk? Okay, I will allow
Yes.
everybody to talk now. Yes.
I think there are only 2 in the class for now.
Yes. So I've allowed them to talk. So others will join later.
Okay.
So put off your
Okay.
camera, please, so that they can
Uh,
concentrate.
let
Yes.
me check it.
You see it's
Okay.
down. Video. Just click on the
Okay.
video and close it. All right. Good.
Okay. Okay. Now.
Uh, All right.
So
So that I
hope you
can.
can hear me clearly.
Yes, I can hear
Yes,
you.
Hello.
sir.
Okay. Mashallah. So now,
Okay. Ab,
I'm still on.
Abdulhamid, can you hear? I've allowed you to talk now.
Yes,
Okay, you can talk now.
yes, sir.
Then
Okay.
Sekina
Okay.
Adekoya can also talk too. Others will
Yes,
join. Let's just continue.
Sekina is he has been cooperating
Okay.
since.
Okay. All
Now,
right.
so the probability scale, we have the probability ranges from 0% to 100%. So for 0%, we have impossible probability. For 25%, which is unlikely, that is 1 over 4. Then 50% is even, while 75% is likely to happen. That is 3 over 4. That is 75 over 100. Then we have 100%. That is certainty. That's probability of certainty. So that is that on the first slide. So let's move on. So please, the summary of this slide is, you know the definition of probability and know the range of values of probability. Then the terms used in probability. Then we have the probability scale. So that's the first slide. Then we move to the second one. So the second one will be on the formulas to use for the probability. So we have the formula to use for the probability. So let me broaden the note so that you can see it. So now, for probability of this form, so whenever you hear probability, please, you have to think of the fraction. Whenever you hear about probability, think of the fraction of numbers. So now, probability of equally likely outcome is given as what? Probability equals to number of successful trials all over total number of possible trials. So according to this note, this definition, the formula to use for probability is number of successful trials all over total number of possible trials. So since form of probability is in form of experiment, so probability is form of experiment, at times it will be they already made the outcome. So we know the answer already. They performed the experiment, we just give them the value to use. But at times, it's going to be live experiment. But in terms of exam purpose, we normally use the already made outcome result. So now, the probability formula is now number of successful trials. At times, they call it number of required outcome. Number of required outcome or number of event space. So if you look at the first note, we have the event space out of those terms used in probability. So number of successful trials all over total number of possible trials, or number of required outcome all over number of possible outcome, or you can say number of event space all over. So I use n of e all over n of s. So n of e means number of event space, e stands for event, and number of sample space. So S stands for sample space. So another formula is relative probability or relative, at times they call it relative frequency or relative probability. It's still probability. So we are still going to make use of probability formula. And the formula is frequency of the event. So this is when you are dealing with frequency table. So if you are dealing with frequency table, we make use of relative probability or relative frequency probability. And the formula is number of the event, frequency of the event all over total number of possible trial, or you can say total number of frequency or total frequency. So which is the same thing as the first formula we have, that is n of e all over n of x. Then now, if you look at this formula, the one with the cursor, I place my cursor on. So the relative probability is the same thing as relative event. Relative frequency. So just make what I did there was to make expectation of an event. Expectation of an event is the frequency of an event. So it's the frequency of an event. So just make it the subject of formula. So if you cross multiply, it's just like, let me try and write it here. Let me write it here. Okay. Hope you can see it. So relative frequency. So it will be relative. I use RF. Let me bold my. Okay. So now. So relative frequency, I will use RF equals to expectation of an event E all over number of trial. So number of trial. So I will use S for number of trial. Or total number of trials, yes. So now, expectation of an event is the same thing as frequency of an event. So if you now cross multiply, if you cross multiply like this, so it's now going to be E equals to, which is expectation of an event, equals to relative frequency, relative frequency multiplied by number of trial, that is S. So that is why we have this last formula. So expectation of an event equals to relative frequency or relative probability multiplied by number of trials. That is the total number of trials. So that is that on the second slide. So the first formula here is number of successful trials all over number of possible trials. Then the second one is relative probability or relative frequency equals to frequency of an event or of the event all over total number of frequency or total number of possible trials. So which is the same thing as n of e all over n of x. Now, expectation of an event is to make frequency of an event the subject of formula. So if you make the frequency of the event the subject of formula, it will now be relative frequency, expectation of an event equals to relative frequency multiplied by total number of trials. So let's move to the next slide. So to move to the next slide, I think we are going to have some examples there. So the next slide. So for the next slide, let me close this. So the third one, so we are moving gradually. So look at the third slide. So for example, one says, a bag contains 3 black, so the first example on the probability is a bag contains 3 black, 4 yellow, and 7 red balls. A ball is picked at random from the bag at random. A ball is picked from the bag at random. So what is the probability that it is white? Hello, are you there? Hello?
Yes, sir.
Hello, are you there?
Yes, sir.
Hello?
Yes, sir.
Okay, mashallah. So a bag contains
And
three
you,
black
sir.
ahead. That's thank you. So a bag contains three black, four yellow, and seven red ball. So a ball is picked from the bag at random. What is the probability that it is a white? So solution. So let me write. So solution now. So now what we are going to do, we are going to make use of the formula. So solution,
Mr.
solution.
Dawood. Assalamu alaikum, Mr. Dawood.
Yes, sir.
That question, can you just a little bit
Walaikum salam
enlarge
to
it?
that.
That question, so that they can able to see the question.
Yes, I can. Okay.
Okay, okay,
Can they see?
good, good,
Okay. Is it
good.
okay now?
At least it's like they can read it now. They
That's
can
good.
read it now.
So now,
Okay.
Yes, sir.
okay, mashallah. So the question is, a bag contains three black, four yellow, and seven red balls. So a ball is picked from the bag at random. So what is the probability that it is a what? Probability that it is what? It is a white ball. So for us to get the probability of a white ball, don't forget the formula of probability. That is probability of an event, P of an event, of an event. So P of an event, I'm coming. P of an event equals to, so P of an event equals to, so I will use N of E. And what is N of E stand for? Number of required outcome, number of, okay, let me use N of E. So let me just write it as N of E. N of E. That is number of required outcome, number of required outcome. So N of, bracket open, N of E, all over N of X. N of S. So this is the formula to use. So N of E over N of S. Now, what is N of E here? The event we are performing. So the event we are performing is the probability that it is a white. So it will now be equals to N of, that is number of white. Number of white ball. Number of white all over N of S. N of S is the total. So how many white ball we have there now? So number of white ball is so let's check. Number of white. From the color given, do we have any white ball there? Any color white there?
No,
Please,
sir.
anybody? No. So it's going to be 0 all over total number of ball in the bag. That is 3. Let me write it there so that you can see it. 3 plus 4 plus 7. So 3 plus 4 plus 7. So which is equals to 0 all over what? All over 14. And 0 over 14 is 0. So which is equals to 0. So this is what? This is what we call impossible probability. So it is not possible. In a bag, you have 3 colors: black, yellow, and red. And they want you to bring out white out of it. It's not possible. So this is impossible probability. I think this one is clear to everyone. This explanation is clear to everyone.
Yes,
Hello?
sir.
Yes.
Mashallah. So let's move to the next question. Next example. Let's move to the next example. Now. So example 2. example 2. So example 2 says, so this is question 2. So this is question 2. So question 2 says a bag contains the following set of balls. Number 3, 5, 7. Hope you can see it like this. Okay. So a box contains the following set of balls. Number 3, 5, 7, 9, 11, 13, 3, 2, 3, 5, 8, and 10. So if a number is picked at random, what is the probability that it is number 3? So what is the probability that it is number 3? So solution. So the probability that it is number 3 will be, so probability that it is number 3 will be probability of probability. So probability of 3 close the bracket equals to number of 3. So how many 3 we have? That's the event. So number of 3 then all over total number given. Total number. So all over total number. All over total number or total frequency. So you can as well call it like that. All over total number. All over total number. Let me erase it. Sorry. So all over total number. So now, so which is equals to? So which is equals to? So how many 3 we have in this given question? So how many number we have there? So anybody? Sorry.
3.
So how many 3? That's 3. I'm sorry.
Yes.
So let me take this again. So probability of 3. Probability of 3 equals to number of 3. So that is 3 all over. How many numbers altogether? So let's count. 1, 2. How many? 12. 1, 2, 3, 4. That's 12. So we have 12 all together. So all over 12. And 3 over 12, 3 over 12. 3 over 12 is 1 over 4. So the probability is 1 over 4. So the probability is 1 over 4. So this is 12. So this is 12. So the answer is now 1 over 4. So let's go to some challenging questions. All these ones, they are very simple. So let's move to the next one. So the next example. The next example so example 3, right? Yes, example 3. So let's look at this example together. So the question is, what is the probability of winning the first prize by Dele who purchased 20 tickets in a lottery when 1,000 tickets were sold. So solution. So this one too is simple. What's the probability of what? Of winning the first prize by Dele who purchased 20 tickets. So the probability of Dele to win for purchasing 20 tickets out of 1,000 will now be probability of winning equals to probability of winning. So probability of winning is equals to the number of tickets bought, equals to number of tickets bought by Dele, that is 20, all over total number of tickets sold, 1,000, all over total number of tickets sold, which is 1,000. So which is equals to, so the probability of Dele to win will now be 20 over 1,000. And 20 over 1,000 is 2 all over 100. And 2 over 100 is the same thing as 1 over 50. So which is equals to 1 all over 50. So this is probability of Dele winning first prize for purchasing 20 tickets out of 1,000 tickets sold. So this is another question. So let's move to another sub-heading. I think so, or another question. So let me check. Now, so let me, now, so now we are moving to another sub-heading. Yes, it's another sub-heading. It's another sub-heading. So it's another sub-heading. So we are doing another sub-heading. So which is what? Experimental and theoretical probability. Since we cannot perform the experiment, since we are unable to perform the experiment now, so just use the already made values given in the question. So the question is, so now the note is on experimental and theoretical probability. Experimental and theoretical probability. So I'm trying to explain this now. So experimental probability equals to the number of successful trials. So when you perform the experiment, so it's like you have a coin. So you have performed the experiment. How many times are you going to perform the experiment? So if the question says, what's the probability of having a head? So you throw a coin, let's say once. So what's the probability of having a head? So it can be 50-50 because we have one. So we have one head and one tail. So the experimental probability, according to this note, is number of successful trials all over total number of possible trials. So which is the same thing as f of e, that is frequency of an event, all over summation f. Summation f is the total frequency. So where f of e is the number of times the event occurred, and summation f is the total frequency. So now, according to this note now, experimental probability is f of e all over summation f. That is frequency of an event and total frequency. Then we have theoretical probability. So for theoretical probability, it's just the probability of an event based on equally likely outcome. Like probability of, like in the coin. So they have equal chances. That is, a head has one chance, the coin have one chance. Then when you throw a die as well, you know we have 6 faces in a die. So they have equal chances of appearing. So like one has one chance, 2 up to 6 like that. So that is equally likely to occur outcome. So we now have examples on experimental probability. So examples on experimental and theoretical probability. Examples on experimental and theoretical probability. And we have this question 1. So the question 1 is, in an experiment, a die is thrown 500 times. The table below shows the outcomes. So they performed the experiment already. So we just want to make the established result to solve for the question given. So now, for experimental probability, they said the experiment has performed 500 times. So the table below shows the outcome. So we have the score from 1 to 6, and we have the frequency. So the frequency is the number of times each of those scores appear. So 1 appears 84 times, 2 appears 81 times, 3 appears 88 times, 4 appears 85 times, 5 appears 80 times, and 6 appears 82 times. So the question says, find the relative frequency. After the relative frequency is the same thing as probability. So find the relative frequency of getting Roman figure 1, a 5, Roman figure 2, a multiple of 3. Then B, Roman figure 1, find the relative frequency of getting a 3. Then Roman figure 2, how many times will you expect to get a 3 if the dice is thrown a total of 2,000 times? So in this B Roman figure 2, we are looking for the expectation of an event. So now let's start. So the next slide will be for the solution. So I need to put this side by side so that we'll be able to fill the question. We'll be able to fill the question. So let me. So I'm solving it here. So don't worry, I will broaden the question so that we can see it clearly. So now, here is the question. So now, according to this, we have this table. We have the table here. So the table is given from 1 to 6. This thing is covering the question. It's covering the question. Okay, I'm coming. Hope you can see the question like this.
Yes, sir.
Yes, sir.
Now, so according to the question, I don't want to draw another table again. So just the following. Find the relative frequency of getting a 5. So relative frequency of getting a 5, which is the same thing as probability of getting a 5. So it's going to be number of times 5 appear. That is frequency of 5 all over total frequency. So now, E Roman figure 1. So I'm solving now. E Roman figure 1. Question E Roman figure 1. So probability of a 5 or relative frequency of a 5. So relative frequency of a 5, relative frequency. So RF of a 5 equals to number of 5, that is frequency of 5 frequency of 5 frequency. So all over total frequency. So which is equals to, what is frequency of 5? Frequency of 5 is 80. I'm coming. Frequency of 5 is 80. Frequency of 5 is 80. Frequency of 5 is 80. So frequency of 5 is 80. So 80 all over total frequency. So total frequency is 500 according to the question, because the question says 500 times. So which is equal to 80 over 500, that is 8 over 50. 8 over 50. 8 over 50. And 8 over 50 is the same thing as 4 all over 25. 4 over 25. 4 over 25. So this is relative frequency of a 5. Then the second question, relative frequency of a multiple of 3. So multiple of 3 from 1 to 6. So how many multiple of 3 we have there? That is 3 and 6. So those are the multiples of 3. So it will now be Roman figure 2, solution to Roman figure 2. Roman figure 2. So probability or relative frequency of bracket open multiples of a 3, or multiple of 3 of 3, yes, equals to, so how many multiples of 3 there? That is 2. That is 3 and 6. That is probability of 3 and 6. Probability of 3 and 6. So probability of 3, that is 8 over 500. That is 8. I mean, probability of 3, 88, sorry. 88 all over 500 plus multiple of 3. Another multiple of 3 is 6. That is 82. 82 all over 500. All over 500. So you now add the 88 to 82. So add the two together. So which is equals to, so 88 plus 82, that is 170. So we have 170 all over 500. And 170 over 500 is 17 over 50. So that's 17 over 50. So this is the answer to question Roman figure 1. That is, find the relative frequency of getting a 5 and a multiple of 3. So the answer is 4 over 25 for the first one and 17 over 50 for the second one. Then B Roman figure 1. So B Roman figure 1 is, so let me, B Roman figure 1. So B Roman figure 1, we have to find the relative frequency of getting a 3. So relative frequency of getting a 3, so let me erase this so that I have space for the solution of the second one. So that is that on the Roman figure 1. Then for Roman figure 2, so for Roman figure 2, so for Roman figure 2, so let me, so for Roman figure 2, for Roman figure 2. So Roman figure 2 now. B Roman figure 2. So B Roman figure 1, relative frequency of a 3. So don't let me. So relative frequency of a 3 will be frequency of a 3, frequency of a 3, so frequency of a 3, so frequency of a 3, so it will be relative frequency of a 3, so not 5 again, of a 3 equals to number, frequency of a 3 is what? That is 88, 88 all over 500. So let me use all over 500. All over 500. All over 500. So this is the same thing as 44 all over 250. 44 all over 250. All over 250. So it can be 22 again. So you divide both, you divide through by 2 again. Both numerator and denominator. So all over 125. 1, 2, 125. All over 125. All over 125. So this is Roman figure 1, B Roman figure 1. So this is question B, Roman figure 1, not A. Then B Roman figure 2. How many times will you expect to get a 3 if the dice is thrown a total number of 2,000 times? So this is expectation of an event. That is Roman figure 2. Roman figure 2. Expectation of an event equals to expectation of 3. So expectation of 3. 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 Expectation of 3 equals to relative frequency of a 3, RF of a 3 multiplied by total frequency. Total frequency all over total frequency. So total frequency given in that Roman figure 2, total frequency or total number of times. So total number of times. Total number of times. So let me erase this. So total number of times. Total number of times. So total number of times. Total number of times. Total number of times. Total number of times. So which is equals to relative frequency of a 3. So that is Roman figure 1 that we calculated for. That is 22 over what? 22 over 125. So we are going to write that. That's 22 over 125. 22 over 125. So let me write it. So expectation of a 3 equals to 22 22 all over 125 multiplied by total number of times given in the question. That is what? That is 2,000. So multiply by 2,000. Multiply by 2,000. So if you multiply, so it's going to be 22 multiplied by 2,000 divided by 22 multiplied by 2,000. That is 44,000. So you have 44,000. 44,000 divided by 125. Divided by 125. Divided by 125. So if you divide 44,000 by 125, you are going to have 352. So 352 times. So that is expectation of an event. 3 will appear. 352 times. So this is the answer to Roman figure B, Roman figure 2. Hello, hope you can hear me. So 352 now. So mashallah. So this is B, Roman figure 2 under experimental probability. Under experimental probability. So that is that. So let me check if we still have another question here. So let me check if we have another question here. So if we have another question here. So we have another question. So we have another question here. So let me see. So under experimental probability. So I think we have done all this. Page 2. So now, let me move this away. So, I'm coming. So I'm coming. I want to check this. Okay, we have done this. So we have done this. So then it remains this. So it remains. Okay, we have done this as well. We have done this as well. Okay. Okay. So hello. Okay, I think this is the last. This is the next.
We can see your screen, Mr. Dawood. Sorry, we can see the question. Okay, you are enlarging it now. Please enlarge it further.
I'm bringing it up.
So I want to solve MCM. If I ask the difference from HCM.
Enlarge it further, please.
Okay. Yes. Okay, can you see it now? Yes. So this is
Okay,
you can see
okay, we can see it now.
bag contains a bag contains red, black, and green identical ball. A ball is picked and replaced. A ball is picked and replaced. It's like we have not done this. Okay, yes, and replaced. Yes, is correct. So find the experimental probability of picking a green. So let me take this as classwork for you. So now, I want someone to answer this question for me. So the table shows, the table below shows the result of 100 trials. So find the experimental probability of picking a green ball. So what's the probability of a green ball here? Probability of a green ball. Sakina, can you answer it? Probability of a green ball.
Sir.
What do you say? What's the probability of a green ball? What's the probability of a green ball? That is number of green ball all over total number of trials. So
That's
number of
4
green
over
ball is
25.
that is
4
4
over
over
25.
25. It will be 16 over 100. So probability of G, PR of G, yes, that's good, mashallah. Probability of G, P of G, P of G. So we use big G for grain. So probability of G equals to number of grain, that is 16, all over total number of trials, 100. So all over 100. So number of G, 16, all over number of trials. So which is 4 all over 25. So 4 all over 25. So this is probability of a grain, all over 25. So if you are looking for probability of black, it will be number of black. So which is what? Number of black is, so number of black is 30 all over 100. So it will be 3 all over 10. So if we are to be probability of red, it's going to be 54 all over 100. So and so on like that. So let me see if we can see one more question to do. We can see one more question to do before we call it a day.
Well
So
done,
before
Mr.
we
Daoud.
call it a day.
It's play again
Now,
now. Only energies.
Right. You
what
just
is it?
have few. No, thank you, sir. Thank you for your work. You just have few minutes left
Thank
for today. The class will end by 3. Though you can, it
Okay.
depends on you can extend it if you feel that you still have something to explain to them so that they can get it. All right.
All
Okay.
right. I
Okay.
think the okay. Now
Yeah.
let me just check the slide. Okay. So I think we are going to continue tomorrow, inshallah. So let's call it a day. So let me see the next slide. Maybe it's another question, but I can just display it as assignment for them. So they should copy it as assignment. They should copy it as assignment. Then tomorrow we continue from where we stop. So hello, please. I want you to copy this question as assignment. So the question is: a fair dice is strong. A fair die. So that is a die is strong. Find the probability of getting a 5, B, an even number, C, a 3 or a 4, D, not an even number, E, an or a 8, an 8, sorry, and F less than 8. So this is what? This is your assignment question. So thank you and God bless. So we shall meet in peace tomorrow and not in pieces. So thank you. Hello. Let me stop this. So